Good day! So this video aims to discuss about the general geology. Mainly topic is geology and engineering and branches of geology. So first to discuss what is geology. Geology it is a branch of earth science concerned with both liquid and solid earth, the rocks of which it is composed, and the processes by which they change over time. This describes the structure of the earth on and beneath its surface and the processes that have shaped that structure. So geology also provides the primary evidence for plate tectonics, the evolutionary history of life, and the Earth's past climates. So currently, the modern geology significantly overlaps all other earth sciences, including hydrology and atmospheric sciences, and so is treated as one major aspect of integrated earth system science and planetary science. So in relation of geology and civil engineering, the fundamental understanding of geology is so important that it is a requirement in university level civil engineering programs. So, for a civil engineering project to be successful, the engineers must understand the land upon which the project rests. We have the geologists who study the land to determine whether it is stable enough to support the proposed project. So, they also study water patterns to determine if a particular site is prone to flooding, while some civil engineers use geologists to examine rocks for important metals, oil, natural gas, and groundwater. So we all know that every civil engineering works involve Earth and its features, and these geological informations are necessary in every stage of the project, be it the planning, designing, or construction phase of the project. So, the importance of geology in civil engineering. So, engineering geology deals with the study of the structure of the earth in relation to the civil engineering for the execution of safe and cost effective design for construction projects. The importance of geology in civil engineering may be briefly outlined as follows. So, first one, we have geology provides a systematic study of the structure and properties of construction materials and their occurrence. So, the civil engineers need to know the properties of rocks accurately to enable them to consider different rocks for any required purpose. Second, the selection of site is important from the viewpoint of stability of foundation and availability of construction materials. So, the geology provides knowledge about the site used in construction of buildings, dams, tunnels, tanks, and etc. Third, the geology helps to identify areas susceptible to failures due to geological hazards such as earthquake, landslides, weathering effects, and etc. Fourth, the knowledge about the nature of the rocks is very necessary for tunneling, constructing roads, and in determining the stability of cuts and slopes. Fifth, the foundation problems of dams, bridges, and buildings are directly related to the geology of the area where they are to be built. Sixth, the knowledge of groundwater is necessary for connection with excavation works, water supply, irrigation, and many other purposes. Seventh, geological maps help in planning civil engineering projects. It provides information about the structural deposition of rock types in the proposed area. Eighth, geology helps in determining the earthquake-prone areas. If any geological features like faults, folds, etc. are found, they have to suitably treated to increase the stability of their structure. Ninth, the knowledge of erosion, transportation, and deposition by surface water helps soil conservation, river control, coastal, and harbor works. And lastly, a geological survey of a site before starting a project will reduce the overall cost. So these are the main reasons why civil engineering students are taught geology in their curriculum, and also it illustrates the importance of geology in civil engineering. So, geology is a relatively recent subject in addition to its core branches. Advances in geology in allied fields have led to specialized sciences like geophysics, geochemistry, seismology, oceanography, and remote sensing. So, these are the branches of geology. The vast subject of geology has been subjected into the following branches. So, first one we have physical geology. So, this is also variously described as dynamic geology, geomorphology, etc. So it deals with different physical features of the Earth, different changes occurring on the Earth's surface, natural phenomena, geological work of wind, glaciers, rivers, oceans, and groundwater, and their role in constantly molding the Earth's surface features. So second, we have mineralogy. So this deals with the study of minerals. Minerals are basic units with different rocks and ores of the earth are made of. So details of mode of formation, composition, occurrence types, association, properties, use, etc. of minerals form the subject matter of mineralogy. So for an example, sometimes quartzite and marble resemble one another in shine, color, and appearance, while marble disintegrates and decomposes in a shorter period because of its mineral composition and properties. Next, we have petrology. So petrology deals with the study of rocks. This is the most important branch of geology from the civil engineering point of view. So the Earth's crust, also called lithosphere, is made up of different type of rocks. Hence, petrology deals with the mode of formation, structure, texture, composition, occurrence, and type of rocks.
The next branch is the structural geology. Structural geology is a subdiscipline of geology that studies how rock deform in response to the stresses that act within the earth. The analysis of geological structure is aimed to understanding why, how, and when the earth deformed. By means of structural investigation, it is possible to constrain the mechanical laws that controls how deformation is taken up by geological materials, and to reconstruct the evolution of mountain chains in space and through geological type. Structural studies are also crucial for the compilation of modern geological maps and cross-section, that is, the tools that we use to illustrate how rocks are distributed on the surface of the earth and at the depth below it. The next branch is the stratigraphy. The climatic and geological changes, including tectonic events in the geological past, can also be known from this investigation. Stratigraphy is the classification of different layers or layering of sedimentary deposit and in-sedimentary or layered volcanic rocks. This field is important to understanding the geological history and forms the basis for classification of rocks into distinct units that can be easily mapped. Stratigraphy is therefore the key to understanding the structure of the bedrocks in time and space. The next branch is the economic geology. Economic geology is a discipline of science that focuses on the earth materials that can be used for economic or industrial development purposes. Often, much of the purpose of the study is to identify new ore deposits for excavation as well as understanding how ore deposits are generated and localized within earth crust. Minerals can be grouped as general rocks forming minerals and economic minerals. Some of the economic minerals like talc, graphite, mica, asbestos, gypsum, magnesite, diamond, and gems. The details of their mode of formation, occurrences, classification, association, varieties, concentration, properties, uses from the subject matter of economic geology. The next branch is engineering geology. This deals with the application of geological knowledge in the field of civil engineering for the execution of safe, stable, and economic construction like dams, bridges, and tunnels. It also served the purpose of assuring that the geological factors regarding the location, design, construction, operation, and maintenance of engineering works are recognized and accounted for.
Mining geology. Mining geology, this deals with the application of geological knowledge in the field of mining. A mining engineer is interested in the mode and extent of occurrence of ores, their association, properties, and etc. It is also necessary to know other physical parameters like depth, direct, inclination, thickness, and reserve of the body for efficient utilization. Such details of mineral exploration, estimation, and exploration are dealt within mining geology. Geophysics. Geophysics is the study of physical properties like density and magnetism of the earth or its parts. To know its interior form, the subject matter of geophysics. There are different types of geophysical investigation based on the physical property utilized gravity method, seismic method, magnetic method. So, engineering geophysics is a branch of exploration geophysics which aims at solving civil engineering problem by interpreting surface geology of the area concerned. So, electrical resistivity method and systemic refraction methods are commonly used in solving civil engineering problems. Geohydrology, also called hydrogeology, it deals with occurrence, movement, and nature of groundwater in an area. It has applied importance because groundwater has many advantages over surface water. So, in general, geological and geophysical study are together taking up for groundwater investigations. Geochemistry. Geochemistry, this branch is relatively more recent and deals with occurrence, distribution, abundance, mobility, etc. of different elements in the earth crust. It is not important from the civil engineering point of view.
And that will be all the discussion about the geology and engineering and branches of geology. Thank you.